Good morning. Welcome to ASTA Academy. Today we are going to look at linear equations in two variables. Okay. In the last class we looked at linear equations in one variable, different types of problems that can come on SAT and so on. Okay. So today let us focus on linear equations in two different variables. Now why this topic is important? From SAT point of view, this topic is important from various reasons. Okay? It allows us to, or we can learn how to draw, create a line from the descriptors given, from the descriptors of the line. What are the descriptors of the line? We will learn slowly, in this chapter. These are the slopes, a point that is given through which the line passes, and sometimes the intercepts. Okay, intercepts. What are the intercepts? These also we will learn, very shortly. There are questions on SAT on linear models, and these are real world examples from real life. Okay, so there will be in context problems or the word problems from real world examples. Okay, for example, these could be cost versus quantity type of problem. These could be rate type of problems. Okay, so these will be drawn from different areas in the real world. Okay, then this topic will also help us in comparing two lines. Okay, there may be two lines given to us. They may be either parallel to each other, they may be either perpendicular to each other, or they may be intersecting. Okay, so we need to be able to identify by looking at those lines and calculating, estimating some of the descriptors or the parameters of the equation. So we will learn about these things. What we are going to learn in this chapter will set the stone or will provide you the foundation, okay, for some advanced topics later on that will come in this chapter, algebra. For example, systems of linear equations or inequalities or system of linear and non-linear equations. Okay, you can expect 3 to 4 questions. 3 to 4 questions from this topic, that is linear equations in two variables, in your DSAT. Okay, so that is why we are saying that this topic is important. Okay, now let us move on and look at the basic concepts on linear equations with two variables. Okay, the standard form of linear equations in two variables is ax plus by is equal to c. Okay, as you all may know, where your a comma b comma c are what? These are some numbers. Okay, they could be integers, they could be real numbers. Okay, and what are x and y? X and y are unknowns. Unknowns, or you can say the variables or the variable quantities, or which can change their value. Okay, now the power of x and y has to be 1, cannot be 2 or 3, then it will become non-linear equation. So because we are in the linear mode right now, so their power has to be 1. And there is one other condition which says at least one of A or B should not be equal to 0. Okay, at least one of them should have some value. Okay, if A is 0, B can't be 0. If B is 0, A can't be 0. Otherwise it will not be a linear equation at all. Okay, once we have this equation, and if we find out certain points on it, okay, and then we try to graph it. If we graph it, how will it appear? It will appear as a straight line. Okay, so this is the basic concept of your linear equation in 2 variables. Okay, now let's see, we looked at the linear equation in 1 variable earlier. Okay, this one has only one solution. Okay, all right, in general form. Okay, we looked at some special cases, we are not talking about those. However, the linear equation in 2 variables, has infinitely many solutions. Okay, it has infinitely many solutions. Well, when we talk of solutions, what are the solutions? What are the solutions?
Pause karo, pause.
Okay, so what are the solutions? Essentially, every point, let's say x comma y on the line, that will satisfy the equation. Left hand side will be equal to right hand side. So these are all the all the points that you can think of will be the solution on the line. So there are infinitely many solutions for a linear equation in 2 variables. Okay, now we are going to look at some key concepts. Okay, and what I'm going to be able to do is bring this up a little bit. So there are certain key definitions we are going to look at next, and those are here. Okay, so these are the let me see if I can get this. Yeah, so you have this first term which is called the slope. Okay, it's a measure of a line's steepness or the change in y for each unit change in x, and it's often written as x. Okay, so this is what is called the slope. Then there is another term called y-intercept, which is a point where the line crosses the y-axis, where x is equal to 0, okay, often written as b. What is an x-intercept? Well, the point where the line crosses the x-axis, where y is equal to 0. Okay. Then there are different types of forms of the equation. We will look at these in more details little later. First one is the slope-interceptor form, which is given as y is equal to mx plus c, where m is the slope and b is the y-intercept. What the point slope form? Y minus y1 is equal to m into x minus x1. So x1 and y1 is the point through which the line is passing. Okay, so this type of form of a linear equation in 2 variables is useful when you know a point x1, y1 and the slope m. Right, so m we need to know, and y1 and x1 we need to know. Then there is a standard form which is ax plus by is equal to c, and we looked at the very beginning, which is useful for finding the intercepts quickly. Okay, we'll take up an example a little later. Then there are the cases of parallel lines and perpendicular lines. These are the basic definitions. Two lines are that never meet. Okay, they will have equal slopes, and we'll look at this in more detail a little later. And then when you have the two lines that meet at right angles, they are called the perpendicular lines. So we'll be looking at the certain descriptors, how we can find by given two equations, we can find out whether they are parallel or perpendicular. Okay, and in case of perpendicular lines, their slopes are negative reciprocals. Okay, so with this, let us look at slope. All right, next concept is the slope from 2 points. How do we find the slope of a line once we are given that it passes through the 2 points? And let's say the 2 points are x1, y1 is one, and x2, y2 is the other. Okay, we have an equation which passes through these 2 points. The slope m is given by this formula, which is essentially rise divided by the run. How much the line rises and how much the line runs in the x direction. This is equal to y2 minus y1 divided by x2 minus x1. Okay. Let us take up an example. You have let's say 2 points 3, 7 and 8, 22. So these are the 2 points, and you have to find the slope of this line, and the line passes through these 2 points. As per the definition, what is this? The rise is y2 minus y1. What is y2? This. Y1 is this. Okay, so it is going to be 22 minus 3 divided by see, m is going to be 22 minus 7 divided by 8 minus 3. Okay, and if you calculate it, it will be 15 divided by 5, sorry, and then it will be m is equal to 15 by 5 will be 3. Okay, so that is your answer for this particular example. Okay, now when we talk of slope, there are certain special cases of the slope. Okay, number 1, m is equal to 0. You can have a line in which rise is 0. It does not rise. Okay, that means it is a horizontal line. Okay, it's a horizontal line, and it will have a form of something y is equal to 5 or constant, and that constant can have any value. Okay, number 2, m is not defined or undefined. Okay, it rises so much that it can't be defined. Okay, so this situation will occur when you have a vertical line. That is, x is equal to constant. Any line on which x is equal to constant is a vertical line whose slope is not defined. Why? It's not defined because dividing by 0 is not allowed. Not allowed. Okay. Then we can have another case of a special type of slope in which the value of m is positive. That means what? That means that line goes up as we go from left to right. Okay, it will be something like this. Okay, then you can have another case in which the slope is negative. Negative meaning the line goes down as we go from left to right. Okay, so if you have a line that goes down like this, its slope is going to be negative. So these are some of the special cases of the lines. Now we come towards what are the common forms of the line. Okay. Remember, we are looking at linear equations in two variables. Okay. There are three different types of forms of line in which we can represent. All right. First one is slope-intercept form. Slope-intercept form. What is this? This will be written as y is equal to mx plus b. Okay, right. And we know both m and b. Okay, once we know these, we can write the equation in this form. Okay, how do we graph this type of situation or this type of equation? If you have to graph it, you can use these steps. Okay, first you can plot a point 0 comma b when x is equal to 0 means the y-intercept, which is already known, b. Then we use the slope. Okay, what is slope? Rise and run this information, okay, to get another point on the graph. Okay, and once you have the 2 points, you can just join them. Okay, so for example, let's say you have an equation in the slope-intercept form given as y is equal to minus 2x plus 3. Okay, so you can try and plot it here like this. Okay, so what is the first point? What's the y-intercept here is 3. X is equal to 0, y is equal to 3. So this is the first point we can quickly plot. Okay, x is equal to 0 and y is equal to 3 is, let's say, here. This is one point. Okay, now the slope is given as minus 2. Now we have m is equal to minus 2, meaning what? The rise is negative 2 units when the run is 1 positive unit. Okay, so what we do is we come down 2 units and go 1 unit on the right. So this is another point. See, so we are coming down 2 units and we are going in the positive x direction 1 unit. So these are the 2 points, and then you can make this line like this. So this is the process of graphing a line from a slope-intercept form in case you need to do it. Okay, so this line is y is equal to minus 2x plus 3. Okay, so this point is 0 comma 3. All right, and this point is 1 comma 0. Okay, I'm not writing it. Now the second type of line form is the point slope form. Point slope form. Okay, in which what is known? The slope is known, and it is also known that this line passes through a given point x1 comma y1. Okay, if this is the type of situation in which these two things are given, then you can write the equation as y minus y1 is equal to, the slope is y2 minus y1 divided by x2 minus x1. We have seen it already. This is the slope. And then x minus x1. So this is the equation in the point slope form. Example. Let's take an example. We have to write an equation which passes through 4, 1 with m is equal to 2. Okay, we can quickly do that. So y minus y1, y minus y1 is 1, okay, is equal to slope is 2 into x minus x1, which is x minus 4. Okay. The right hand side, you use the distributive property and distribute the 2 into the two terms. So it will be 2x minus 8. All right. You take the 1 on the other side. So you will have y is equal to 2x minus 7. Okay. So this is your answer to the question to find the equation of a line which passes through point this and which has a slope of 2. Now there is a third form of the line which is called the standard form, and we saw this in the very beginning. Okay, this is essentially useful in finding the intercepts. On SAT you will find some problems where you will need to find the intercepts. Okay, and the standard form is ax plus by is plus c is equal to 0. This is the standard form. Okay, so now if you have to find the x-intercept, okay, if you have to find the x-intercept, that is the point where the line cuts the x-axis, what's the value of y? Y is 0. And if you have to find the y-intercept, that is the point where the line cuts the y-axis, there your x will be 0. Okay, so this is extremely important. Okay, many students make mistakes here. Okay. Now let us look at an example. Example is find the both the intercepts, x-intercept as well as y-intercept for this line 2x plus 3y is equal to 12. Okay, so let us quickly find the x-intercept. How do we do that? We simply put y is equal to 0 in the equation. So that will give you 2x plus 0 is equal to 12 or x is equal to 12 by 2, which is 6. So the intercept is 6, 0. Excuse me. How to find the y-intercept? We just plug x is equal to 0 in the equation. That will give us 0 plus 3y is equal to 12. Okay, or y is equal to 12 by 3, which is going to be equal to 4. Okay, so the point is 0, 4. Okay, so we are able to find this is the point where the line crosses the x-axis or x-intercept, and this is the y-intercept. Okay. Okay, let's continue and look at another important topic within linear equations of two variables. Okay. Now we are looking at essentially the parallel and perpendicular lines. Okay. All right. All right. So let us look at the parallel and perpendicular lines. How do we determine whether the two given lines are parallel or perpendicular? Let's say they are given in this form. Y is equal to m1x plus b1 and y is equal to m2x and b2. Okay. So these are the two equations given to us in the slope intercept form. The first line has a slope of m1 and an intercept of b1. Second line has a slope of m2 and an intercept of b2. Okay. Now let us look at the case of parallel lines. Two lines are parallel. There are two conditions that have to be satisfied, and I am writing IFF in mathematical terms. It means if and only if the two lines are parallel, if and only if there are two conditions. One is their slopes are same. Slopes are same means m1 is equal to m2, and both the conditions have to be satisfied. They have different y-intercepts. That is, your b1 cannot be equal to b2. So if they have different intercepts but same slope, then they are parallel lines. Example, let's say y is equal to 3x plus 1 and y is equal to 3x plus 7. They are different, they are same. Slopes are same, intercepts are different, means what? They are parallel. Okay. What about these two equations? Y is equal to x plus 2 and y is equal to x plus 2. In this case, their slopes are same, but these are also same. Okay. So when both the things are same, then essentially it's only one line. These are not two lines. Okay. So we can't call them parallel because they meet at every point. Okay. Parallel lines never meet with each other. Now the next concept is about the perpendicular lines. When can the two lines be perpendicular? Again, if and only if their slopes are negative reciprocals of each other. So what are the conditions? m1 into m2 is equal to minus 1. So when you multiply the two slopes of the two lines, the resultant or the product should be negative 1. Or m1 is equal to minus 1 upon m2, or m2 is equal to minus 1 over m1. Okay. Example, if your m1 is 4, what will be the slope of a line which is perpendicular to this one? It will be minus 1 by 4. And if m1 is, let's say, 2 by 3, what will be m2? Negative reciprocal 3 by 2. Okay. So essentially what we are doing? We are doing flipping the fraction. So to find the slope of the perpendicular line, you just flip the fraction and change the signs. If it's negative, make it positive. If it is positive, make it negative. Okay. Now we come to another important topic we talked about in the beginning on linear modeling. Okay. Linear modeling is a type of questions you will get when a paragraph is given, in context problem is given, and you need to assume some x variable, y variable, there's some relationship given, and you need to establish that relationship and then solve it. Okay. So the real world problems will be coming and you need to be able to solve them. As I said, these are in context type of problems or the word problems. Okay. Now in these, the slope and the intercept have special meaning. Okay, when you read the paragraph, okay, slope and intercept should be obvious. Okay, so the y-intercept or b will be the starting point or starting value in the problem, or you can say the initial value. Okay, or some fixed amount. So if you read a sentence which talks about certain fixed amount or some initial value, some starting value, that is your equivalent to the y-intercept or b. Okay. What is the slope? Slope will be the rate of change. Slope will be the rate of change per unit of another quantity. You may have cost, you may have speed, you may have, depending upon the context, you may have different situation. Okay. Now what I would like to be able to do is take up an example, and here it is. Okay. So in this example we see that a gym charges $25 per month plus a 50 sign-up fee. Plus a 50 sign-up fee. Okay, this tells us something. We need to be able to write a linear equation for the total cost. See how much is the total cost after m months. So m is a variable, cost is another variable. M is the independent variable. Okay, time does not depend on anything. Cost depends upon the number of months. So cost is like y, m is like x. Now the fixed cost or the sign-up fee 50, it's charged only once. So this is fixed. So this is the y-intercept, or b is equal to 50. What's the variable cost? It's the monthly fee. Every month it increases by $25. Okay, the total cost will increase by a rate of 25 per month. All right, so this is your slope of the line. Okay, so you can write the equation as c is equal to 25m plus 50. Okay, so 25 is representing the cost per month and c is representing the total cost. Okay, with that we come to the close of this lecture. I hope you have enjoyed it. Thank you very much.